Good day everyone, you are welcome to this tutorial. In today's tutorial, I want to show you how to calculate top of atmosphere spectral radiance from Landsat image. And in this exercise, we are using Landsat 8. But first of all, what do we mean by top of atmosphere spectra? Now, top of atmosphere spectral radiance refers to the amount of electromagnetic energy reflected or emitted from the Earth's surface and atmosphere, and it is measured at the top of atmosphere. It is typically expressed in unit of watt per square meter per steradian per micrometer and is crucial for remote sensing application. This top of atmosphere spectral radiance has application in remote sensing. In remote sensing, the top of atmosphere spectral radiance is used to analyze and monitor land cover, vegetation health, and water quality. Similarly, it has application in climate studies as it helps in understanding the Earth's surface energy balance and assessing changes in climate by tracking variation in solar radiation absorption and reflection. Similarly, it has application in agriculture monitoring. The top of atmosphere spectral data support crop health assessment, yield prediction, and precision agriculture by analyzing vegetation indices. Similarly, it has application in weather forecasting. So meteorologists use top of atmosphere spectral radiance measurements to improve weather models and predict atmospheric phenomenon. And lastly, this top of atmosphere spectral radiance has application in disaster management. So to calculate it, I will show you step by step in this tutorial. Then the formula for calculating top of atmosphere spectral radiance is this. Let me make this bold for you to see it more. Yes, you can see the formula for calculating top of atmosphere spectral radiance. L lambda is equal to ml multiplied by qcal plus al, where L lambda refers to the top of atmosphere spectral radiance, and as I said earlier on, it is measured in watt per square meter per steradians per micrometer, and the ml is the radiance multiplicative band, and al is the radiance add band, while qcal refer to quantized and calibrated standard product pixel value, and it refers to band 10. In this exercise, we are going to use Landsat 8 band 10. The ml and al, we are going to get it from the metadata of Landsat 8. So let's get started. Now, I've downloaded my Landsat image and I've extracted it. You can watch how to download Landsat image in the description box. I've done a video previously on how to download it from USGS site and even Glovis. So this is Landsat 8 I've downloaded. If I open it, I have band 1 to band 10. Now we need to make use of the MTL file. This is MTL file. When you download Landsat image, you will see the MTL file. You have to open the MTL file by right clicking and open with. Then you can open with WordPad. Click and open. When it opens, depending on the Microsoft Office versions you are using, the words may look something like this. And for us to see it clearly, let's just highlight all. Then let's change the font to Calibri. So let's change it to Calibri. Yes, it's fair like this. And if you scroll down, these are metadata of the Landsat 8 we want to use in this exercise. And most essentially, the metadata we are concerned about is the radiance multiplicative band and radiance add band. Now, if we go back to the formula, I told you that ml refer to radiance multiplicative band, and AL, radiance add band, while QCal is the band 10 we want to use. So now let's go to ArcGIS. In ArcGIS, the first thing to do is to bring the band, which is band 10. So click on Add, navigate to your data. I'm using band 10. Here is band 10. Select it and click on Add. So here is band 10. Now to calculate the top of atmosphere spectral radiance, I've shown you the formula. Here is the formula. We are going to use the raster calculator to input this formula. So top of atmosphere spectral radiance is equal to ml multiplied by kcal plus al. So let's go to ArcGIS. So in ArcGIS, to do the calculation, come to Arc Toolbox, then come to Spatial Analysis tool. Scroll down and come to Map Algebra, expand it, and here is raster calculator. So double click and open the raster calculator. Now here you will input the formula here, and as I told you, here is the formula. Recall the formula, that is ml, and ml is radiance multiplicative band. So go back to that mtl file we opened. Here we look for radiance multiplicative band 10. Since we are using band 10, let me drop this so that you can see it clearly. So this is the one we are interested in, radiance multiplicative band 10. Here is it. So, and the value here is 3.3420 minus 04. So what that means, we have to convert it to decimal. So that will be equal to, this value you are seeing here will be equal to 0.000342. So by the time you convert it to decimal, this value, when you convert it to decimal, this is what it will give you. So copy, this is our ml, copy it, copy. Then go back to ArcGIS and go back to the raster calculator. So here is our ml we copy. Right click and paste it. Here is the value. Recall our formula, ml, which you have inputted, multiplied by qcal, and qcal is band 10. So let's go back to ArcGIS. So input the multiplication sign, multiply by qcal. Our qcal is band 10, band 10. Then check the formula again, plus al, and al is radiance add band. So here is plus sign, plus al. Let's go back to that metadata. The al refer to radius add band, and in this case we are using radius add band 10. Here is it, and here is the value. You can see the value 0.1. That is the value of our al, 0.1. So let's go back to ArcGIS and add it 0.1. So after putting the expression, remember this is ml multiplied by qcal plus al. After you input the formula, then specify the output raster. So I'll click here. So let's just call this output radiance. Then click on save, and here click on OK. So the process of calculating the top of atmosphere reflectance radiance is going on background, and it may take few seconds to some minutes to calculate it. Yes, the top of atmosphere reflectance radiance has been calculated, and here is it. Here is it. Let me close this. The top of atmosphere reflectance radiance has application in remote sensing, climate studies, agricultural monitoring, weather forecasting, and disaster management. So we can try to change the color ramp for better visualization. Let's change it to this and invert it. Click on OK. Yes, you can see the top of atmosphere reflectance radiance for this area. Thank you for watching.